In 1912, astronomer Vesto Slipher discovered that remote galaxies were exhibiting an unexplained red shift. Everywhere he looked, distant galaxies were showing this, but it was always only the distant ones to this degree. Close ones were lesser, or in the case of Andromeda, blue shifted. At the time, the discoveries seemed to indicate that most of the universe's galaxies were receding from each other, other than the local group, which is gravitationally bound. About a decade later, Alexander Friedmann used Einstein's field equations to discover that, at least theoretically, the universe was expanding. Observational evidence of this came with Knut Lundmark in 1924. Georges Lemaitre came to a similar conclusion and formulated what would become the Big Bang Theory, confirmed by Edwin Hubble in 1929. Since then, an enormous amount of evidence has mounted both for the Big Bang and the expansion of the universe. What astronomers see is not really accountable through any other hypothesis. There were holdouts of the older steady-state universe hypothesis, including Fred Hoyle, but it simply has not observationally panned out. But within this, there lies a huge mystery still. It was first discovered in 1998 through observations of distant extragalactic supernovae, that the expansion of the universe is in fact accelerating. This was not expected. Indeed, you expect it to either be constant or decelerating. But once again, observations have since confirmed that it is indeed speeding up. But for a process to accelerate like that, that means that some kind of energy is needed to drive it, and it needs a lot of it. 68% of the energy of the universe as a whole is locked up in this. It's dark energy, and it has led to a lot of controversy, just like it did for dark matter or anything astronomers term as dark. There's a reason for that. It's all based on a hint. You see an effect, and you know to explain that effect, there is the simplest answer. And the simplest answer in both cases is dark matter and dark energy. But that's all we know, and there have been some that dispute it, of course, and in fairness, dark energy is weird in another respect. While it drives the acceleration of the expansion of the universe, it does not appear to manifest itself any other way. It is a unique form of energy. With dark matter, excess gravity is seen, and the only way to create gravity so far as we know is matter, and thus dark matter, an unknown form of matter that we can't otherwise see. With dark energy, it is an unknown form of energy required to drive the accelerating expansion of the universe. Expansions that speed up don't happen without something pushing them. There have been a number of hypotheses regarding dark energy, but now there is a new one. And it's strange because it may eliminate the need for dark energy, as we see energy in a standard way. It's the idea that our universe is absorbing other universes, which accounts for the expansion. In a paper by J. Ambjorn and colleagues, link in the description below, they lay out the possibility that the answer for the accelerated expansion is very simple. It's not being driven by energy. It's that its volume is being increased as it merges with other baby universes. This then eliminates the need for dark energy as we were envisioning it before, and it actually simplifies the situation by providing a means for the volume increase. Why we would be absorbing universes at an accelerated rate is unclear, but if they are expanding as well, then that might account for it. But this is not the only time that interactions between our universe and other universes has been put forward. But it presumes something, that other universes exist. We don't actually know that's the case because, well, we can't see outside of our universe. But this flavor of a multiverse does solve a number of problems, at least potentially, not the least of which is the fine-tuning problem. That the universe appears to be fine-tuned not just for life, but for the ability for even simple atoms to exist. The parameters could have been anything, and if they had been slightly different, there would be no matter. But they were just so to allow matter and ultimately life. But there's a problem. If another universe can merge with ours, how likely does it seem that the rules of that universe would match ours enough not to destroy one of the two universes, or make them so incompatible that a merger could not occur? Yet it seems that they would both have the same laws of physics. Well, what sets those? We have no idea, so the fine-tuning problem comes back with a vengeance. It would mean that something tunes all universes the same. It's unclear how this model could be tested other than mathematical consistency with what we see, which is obviously problematic. But there have been other instances in the fairly recent history of science that may be pointing to the existence of other universes. It really depends on how those universes interact, if they do at all. And it also depends on what model of the multiverse you're considering. There are several, and some of them aren't really relevant in this context, such as the idea of many worlds constantly splitting off from each other into different alternate timelines. Rather, here it's just a matter of other universes physically existing in a multiverse of some kind, something like billiard balls that move around on a table and occasionally come into contact with each other. One idea on how to detect whether this is the case was advanced some years ago, that there may be imprints of collisions with other universes preserved in the cosmic microwave background radiation. This stems from a feature in the CMB that is often called a hole, but really a distortion of the CMB. Holes or voids in the CMB are simply hot or cold spots that go beyond the normal tiny temperature variations seen with the afterglow of the Big Bang. The feature in question, known as the WMAP cold spot, is particularly puzzling. Now, cold is a relative term because the CMB is actually really uniform in its temperature, almost to a fault. But that it isn't perfectly uniform is important and related to the formation of galaxies and the structures of the universe. That had it not been the case, the universe after the Big Bang might simply have been a lattice of perfectly equidistant atoms of hydrogen that would not have been able to clump together to form stars. The non-uniformity was important. But to put it into perspective, the unusually large cold spot is just 0.00007 Kelvin colder than average for the CMB. Yet it's still there, and there really isn't a reason for it to be so large. The cold spot is roughly in the area of the constellation Eridanus, and one idea is that there is a supervoid between us and the primordial CMB that is distorting what we see. This intervening void would probably be the largest known structure in the universe. It needs to be hundreds of millions of light years across, and very distant, 6 to 10 billion light years away. But that's not the only idea. Another is that it could be the imprint of a collision with another universe entirely. Here the other universe was entangled through quantum entanglement with our own originally, and then the two universes were separated by cosmic inflation. This is interesting because if this can be shown to be the case, then it would be the first actual evidence of a parallel universe, and it's actually testable. What would be looked for is a similar void in the celestial sphere's opposite hemisphere. There is some weak evidence for this. It's highly contested, but nothing particularly solid yet. But it would hold major implications because not only would it prove the existence of at least one parallel universe, it would also provide a significant amount of weight to string theory, which is famously notoriously difficult to prove. Another highly theoretical idea is that the universe is two-sided in another way, in that we are just one side of a two-sided Big Bang, with an anti-universe stretching perhaps backwards through time from the point of the Big Bang. A completely different way to search for other universes are gravitational waves. It has been advanced that certain gravitational wave signatures might signal the occurrence of other Big Bangs. One idea on how that happens is that the period of inflation that the universe went through after the Big Bang does explain certain things that astronomers observe. And it continues, but may at some point stop. When that happens, it may produce another Big Bang. How that would be related to the accelerated expansion of the universe is unclear. Trouble is, it doesn't appear it will stop everywhere at the same time. Rather, it will sort of propagate, which means you could have had multiple Big Bangs. Cue in an experiment, or really a series of them, known as ANITA, or the Antarctica Impulsive Transient Antenna. The results of the experiment were extremely strange and remain anomalous. So the experiment in a nutshell was trying to detect neutrinos. Neutrinos actually are a kind of dark matter. they only very rarely interact with normal matter and mostly pass through everything. So much so that the vast majority of neutrinos encountering Earth will just pass through it and move on in space. This incidentally is one of the reasons why a particle explanation for dark matter is on the table. If the neutrino can be that non-interactive as to pass through Earth unfazed, then could there be other particles that can also do that? Well, yes, there very well could be, which is dark matter. But in regards to Anita, the first strange thing was that most neutrino detections should have been coming from interactions in the upper atmosphere, and they were. But it was found that an inordinate amount of neutrinos were coming up from Earth into the detector from the bottom, looking towards space but finding signals from Earth, as it were. This may sound spooky, but neutrinos can mostly pass through Earth seamlessly. So of course, some coming up from Earth isn't surprising. After all, neutrinos can come from any direction and pass through most everything, except occasionally when they interact. The problem was that these particular neutrinos were very high energy, and that should not be possible. But there were only 3 detections of this, and other experiments didn't seem to show it. It's not ruled out, but not settled either. So this is probably a flaw in the detector. The detections were such that an astrophysical source is unlikely, but a flaw in the equipment is something that can certainly happen, and does. But there is a third option. So the detection was such that if it were not a flawed observation, then it hints at something new in physics, and that could be the existence of another universe. Basically, the idea is that if it violates what can happen in this universe, then what if it came from another universe? That's not the greatest thinking in my view, sort of hand-wavy and building on an uncertainty that was not found in another experiment, but it was advanced in the scientific literature, and the whole thing, whatever the cause, does remain unexplained. At the same time though, what might be even more unsettling than the existence of a multiverse, where every variation of you exists, or some flavor of that, is well explored in science fiction. The more unsettling idea is if the multiverse does not exist, and this is it. This one universe, potentially the only one that's ever existed, that just happened to be fine-tuned for life, coming into existence for unknown reasons, and perhaps is not repeatable. If that's the case, then we really have no idea what, or even who, caused that, nor do we know why it happened. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently informing everyone that the usual strange aspects of the elements and our continued explorations of each of the planets will resume next month. Why? Because I really came up with a lot of spooky season scripts this time around, and I'm not sure I can cram them all in inside a month, which isn't a bad thing. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.